Hi there, folks. Today we're looking at solving absolute value equations. But before we get into solving absolute value equations, let's remind ourselves of what the absolute value is. The absolute value is the distance from zero, okay? And the symbol for absolute value is these two little bars that we put around the number, okay? They fall into the same category as inclusion symbols when we're talking about order of operations. So keep that in mind as well. They are grouping symbols. They go around things just like parentheses, but these guys actually do something, all right? They cause us to count the distance of that value from zero, all right? And if you've ever measured things in terms of distance, like using a ruler or a tape measure, you might notice that there's only positive numbers on a ruler or tape measure. We don't measure things in terms of negative, all right? So when we count to something, even if it is a negative value, we count how many units away from zero it is in terms of the positive, all right? For example, so I've got my number line here. Right here, it says the absolute value of -5. So think about where -5 is right here. Count how far away from zero it is. So here's 0. Ready? Let's count. 1, 2, 3, 4, 5 units away. Okay? And even though we're counting in the negative direction, the distance is 5 units. So the absolute value of -5 would be +5. Okay? If I look at the next guy, it says, hey, the absolute value of 7. So if I count from 0, so 0 is right here, right in the middle. If I count to 7, that's 1, 2, 3, 4, 5, 6, 7 units away. All right. So the absolute value of +7 is also 7. And so one of the things that students start to do is they say, oh, the absolute value always makes things positive. Well, if it's already positive, it stays positive, okay? So when we're measuring things, we always count in terms of positive. So here, the absolute value of 4 would be a 4, okay? It's 4 units away from 0. The absolute value of -6 is a +6 because it's 6 units away from 0, okay? So now we're going to apply that to solving equations. And if we consider the following, so these are really simple absolute value equations. But if I had the absolute value of something equals 5, think about what value would give me a 5 when I plugged it into the absolute value. And there should be one that's really obvious because it's written right above this thing. Notice absolute value of -5 equals 5. So right here, that's telling me that x could be a -5. Right? Because the absolute value of -5 is a 5. But now look back to your number line, okay? The absolute value of -5 was a 5 because that was 5 units away. What other thing is 5 units away? And hopefully you're looking at this and say, well, 5 is 5 units away. That means x could also equal a 5. And wouldn't each of those be true? Like if I substituted in, if I plugged that -5 in for x, the absolute value of -5 is a 5. But if I plug the 5 in, the absolute value of 5 is also a 5. All right, so we're thinking about what things are 5 units away. Same thing with the next one. It says the absolute value of x equals 8. Well, what things would be 8 units away from 0? Well, x could be a -8. That's 8 units away. Or x could be a +8. That's also 8 units away. All right, so each of those has an absolute value of 8 because they're both 8 units away. And so the theme here is that the absolute value, when I solve absolute value equations, I end up with 2 answers most of the time. All right, because there are 2 different things that are that far away from 0. Okay, so when we're talking about the absolute value, if the absolute value equals a 2, well, there's 2 values that are 2 units away from 0. Okay, a +2 and a -2. The absolute value of something equals 5, well, it could be a -5 or a +5. Those are both 5 units away from 0. Okay, and then we look at this guy. There's a little special case here. The absolute value of something equals a -3. Well, when will the absolute value equal a negative? Where is -3 on your tape measure? And the answer is it's not on there, okay? The absolute value will always equal a positive. So if we see the absolute value equals a negative, that's impossible. That's when we say no solution, okay? So again, the idea here is the absolute value typically gives us 2 answers unless we're talking about something like that last one, which is impossible. So watch out for that special case, okay? And so kind of here's how we approach this then. So basically the same thing we were just doing, like when I had the absolute value of x equals 5, it could be a 5 or a -5. Those are both 5 units away from 0, okay? So the absolute value is just like solving 2 linear equations. If I have the absolute value of A equals B, well then A is either the positive version of B or A is the negative version of B. It's either of those 2 things that's that same distance from 0. okay? And here's what that looks like when I do it in terms of a more complicated equation. See, like here, I have the absolute value of x plus 4 equals 10. So ignore that x plus 4 thing. Just say absolute value equals 10. Which two values are 10 units from 0? Well, one of the values that's 10 units from 0 is negative 10. The other value that's 10 units from 0 is positive 10, which means x plus 4 equals negative 10, or x plus 4 equals positive 10. I approach it the same way that I did these guys up here, but instead of just having an x inside there, I have an x plus 4. And all we're saying here is that, hey, that absolute value equals a 10, which means the thing in the absolute value is either a 10 or a negative 10. It's one of those things. And now I solve each. So I always do the positive version and the negative version, and now I solve these two equations. If I solve the first one, subtract the 4 from each side. I was a little off there. Oh boy. I'm having some trouble. So I get x equals a negative 14. And then here, I subtract the 4 from each side. So I get x equals a positive 6. And that's it. Those are my two answers. And watch what happens if you plug it in. If you plug the negative 14 in, you get negative 14 plus 4. That gives me the negative 10. That's one of the values that's 10 units away from 0. So the absolute value of negative 10 is a positive 10. If you plug the 6 in, you get 6 plus 4 is a 10, a positive 10. Well, that's one of the values that was 10 units away from 0. So the absolute value of positive 10 equals a 10. So you can kind of see how that works when you plug them back in. That first value gives me the negative 10, which is 10 units away. The second value gives me the positive 10, which is also 10 units away. And that's it. I just get these two answers. All right. And this is a little different from any other linear equation we've ever solved. Usually we only have one answer. Now we're getting into these situations where we can have more than one answer. Okay. If I look at the next one, same kind of thing. If I look at this, if the absolute value equals a 6, that means I got to think about the two things that have an absolute value of 6, the two things that are 6 units from 0. Well, that would be a negative 6 and a positive 6. So the 2c minus 2 equals a negative 6, or the 2c minus 2 equals a positive 6. And now I'm just going to solve each of these things, okay? Let me scoot that up. I didn't give myself a whole lot of space here. But now I solve each of these the same way I've always solved. So here, to undo subtracting 2, I'm going to add the 2 to each side. And now to undo multiplying by the 2, I'm going to divide by the 2. Same thing with the second equation. To undo subtracting the 2, I'm going to add the 2. Whoop. Clearly, I should be writing in blue when I get to that point, right? I don't want to make anybody feel uncomfortable. So let's, whew. And now to undo multiplying by the 2, I divide by the 2. But again, if you plug these back in, we plug values back in to check to make sure we've done it right. If you plug the negative 2 in, we get a negative 6 in the parentheses, or in the absolute value. Well, that's one of the things that was 6 units away. And the absolute value negative 6 is a positive 6. If you plug the 4 in, you get a positive 6 in the absolute value. That's the other thing that's 6 units away. And the absolute value, that gives me a positive 6. Okay? That's why we end up with two answers, because there's two things that are 6 units away from 0. Okay? If I look at the next guy, it says the absolute value of t plus 2 equals a negative 5.5. Well, think about which two things are negative 5.5 units away from 0. And hopefully you're going, well, I can't measure that far from 0. When I measure, I always measure things in terms of positive. So can the absolute value equal a negative 5.5? And the answer is no. Whoa, this thing just jumped on me. The answer is no, so this one is no solution. Okay? So just watch out for that special case. The absolute value can't equal a negative. The absolute value is measuring how far from 0 we are. Well, we can't be negative 5.5 units away. We measure things as positives. Okay? If I look at the next one's a little bit tricky, because you might be looking at it going, there's a bunch of extra stuff, not just the absolute value. Well, think about in terms of order of operations. Absolute value symbols are inclusion symbols. So we have to undo those last, all right? Which means I have to undo the subtraction. I have to undo the multiplication before I can undo those absolute value. So here I'm going to get rid of the subtracting 4 by adding 4. And you can always also think of it as getting the absolute value by itself first, okay? But again, if I'm working backwards sort of operations, I have to undo the absolute value last. Inclusion symbols go last. So now I have to undo that multiplication. To undo multiplying by 2, I divide by 2. Now I can start talking about getting rid of that absolute value. And so to get rid of the absolute value, I think about what it says. Absolute value equals 3. So let's see, there are two things that are 3 units away from 0. There's a negative 3 is 3 units away from 0. And a positive 3 is 3 units away from 0. So that means that this thing could equal a negative 3 or a positive 3. And now I solve each. Here I subtract the 5. And I get x equals a negative 8. Here I subtract the 5. And I get x equals a negative 2. And once again, if you plug each of those back in, the negative 8, if you plug it into this step right here, is the easiest place to see it. The negative 8 gives us the negative 3 in the absolute value, which is 3 units away. So the absolute value, that equals 3. The negative 2, when you plug it in there, gives me the positive 3, which is 3 units away from 0. So that gives me the positive 3 when I do the absolute value. Okay? But again, the easy way to just think about this is you're just doing the two versions of that thing. Okay? Every absolute value has two different versions in terms of that distance. Okay? So that means whatever I have over there, whether it's a 3 in this example or a 6 in another example, I say this thing equals the negative version and this thing equals the positive version, and then I solve each. Okay? The only other thing I have to do is watch out for that special case. Absolute value can equal negative. That's when it's no solution. Okay? Hi there, folks. Today we're looking at absolute value inequalities. And an absolute value inequality, just like when we're solving absolute value equations, I had to kind of split this thing up into two different things. Well, here in absolute value inequality, I'm going to split up into two different things. So the absolute value equations, I got two different equations. And now with the absolute value inequalities, I'm going to get two different inequalities. But here's the thing, we already have a name for when we have two inequalities. We call them compound inequalities. Remember, we had two types. There was the and inequalities and there was the or inequalities, all right? And so really, if the absolute value inequality becomes two inequalities, it's got to be either this and type of inequality or the or type of inequality. They become compound inequalities, all right? And the approach to this is very similar to equations. So with the equation, remember, we had the absolute value equals something, and I would do it equal to that thing and then equal to the negative version of that thing. It's the same thing here, except when I do the negative version, I have to flip the inequality sign. So if you look at this, like right here, it says A, the absolute value of A is less than B. So I do A is less than B for the first one. And then I do A is greater than the opposite of B for the second one, okay? So I change the sign. When I change the sign, I flip that inequality sign, just like when I multiply or divide by a negative. Here, notice, look at this. It says absolute value of A is greater than B. So I start with A is greater than B. And then when I do the opposite version, the negative version, I flip the inequality sign, okay? And so that's really it, other than the word that goes in between. Notice one of these has the word and one has the word or, and the easiest way to do that is just a little bit of memorization. When the absolute value is less than, it's an and. And notice I just said the word less than a little funny, okay? It's still an easy way to remember it. The absolute value is greater than is an or, okay? So less than is an and, greater is an or, all right? And that's all we have to do to remember to whether to put an and or an or in between there, okay? For example, if I look at something like this guy, so here I've got the absolute value is greater than 10. So when we did equations, we would do the x plus 4 equals the 10. And then I would do the x plus 4 equals the opposite of that thing, which is a negative 10. But now here, instead of equals, I have an inequality. I just copy it down. It's a greater than symbol. And when I do the negative version, I flip it and make it a less than symbol. Okay. Now the only other thing I need to decide is what symbol goes or what word goes in between. Since the absolute value is greater than, So greater is an or, so I put an or in between. And now to solve a compound inequality, I just solve the two inequalities separately. So here I subtract the 4 from each side. Over here I subtract the 4 from each side. My or tags along for the ride, and that's it. This is my answer. The only other thing that I might do here is I would draw a quick sketch of the graph just to make sure my or inequality looks right. I would say, oh, well, let's see, greater than a 6, open dot and shaded this way, less than a -14, open dot and shaded that way. Okay? And that's what or inequalities are supposed to look like. We have two separate pieces, one or the other. Okay? If I look at the next one, same kind of thing. If this was an equation, I would do the +6 and I would also do the -6. But since it's an inequality, I just copy the inequality sign down. But when I do the negative version, I have to flip the thing. Okay? Now I look at it and say absolute value is less than. So less than is an and. So I just put the word and in between. And now I solve each of these separately. So here I add the 2 to each side. And then divide by the 2. Over here, same kind of thing. I'm going to add the 2 to each side. And then divide by the 2. That and tags along to the ride, but now wait a minute. This is not how we usually write and inequalities. Remember, and inequalities we usually write as one string, so remember it's always least to greatest. So the C is -2, so the C is between a -2 and a +4, and then I can fill my less than symbols in between there. Okay, that's what an and inequality typically looks like. If you write it with the word and in between, that's going to be okay. That's technically correct, but this is the best way to write our answer. Okay, and when you go to graph it, it's easy to see that the -4 is, the C is between the -2 and the +4. In fact, when you look at those original inequalities, it says less than or equal to the 4 and greater than or equal to the 2. So bigger than the 2 but less than the 4 is in between the -2 and the 4. Okay? If I look at the next one, same kind of thing. I say, hey, I've got the t plus 2, so I use the 5, but then I also use a -5, just like I do with the equations. But instead here, I copy this inequality sign. When I do the negative version, I flip it. Absolute value is greater. Greater is an or. And now I solve each of these. Subtract that 2 from each side. T is greater than 3. Over here, I subtract the 2 from each side. T is less than a -7. Then we slap our or symbol down. That's it. Okay, let's draw a quick sketch of the graph, because that feels good, right? -7, +3. Let's see, it says we're greater than the 3. That's like this. Less than the 7's like this. Notice my use of those open dots. And that's what an or inequality is supposed to look like. Remember, we have the two different pieces, okay? The next one here, again, we got to isolate the absolute value first because we're working backwards through order of operations. Absolute value is inclusion symbols, so we undo those last. So I need to undo that times 2 first. To undo multiplying by 2, I divide by 2. Now I'm left with just the absolute value. To get rid of the absolute value, that's when I start breaking this thing up. I get rid of the absolute value by doing the x plus 5 with the 1 and the x plus 5 with the -1. And now I copy this guy down, but I flip the inequality symbol when I do the negative. And now I solve each of them. Oh, wait, sorry. Let's put the and or the or in there first. Absolute value is less than, so it's an and. Remember, less than is an and. Now let's solve each. Here I subtract the 5 from each side. So I've got x is less than or equal to a -4. Here I subtract the 5 from each side. I get x is greater than or equal to a -6. The and tags along, but that's not how I would normally write an and. Normally I write the -6 first, least to greatest. And then look at the symbol here, see? The alligator is pointing towards the x. And now combine it with this piece, the x and the alligator pointing towards the -4. Okay? And then, of course, the graph of this thing. I'm really squeezing this in here. We've got a closed dot at each, and I'm shading everything in between. That's how and inequalities work, okay? The last one here, it says a company producing boxes of crackers have a 5-gram margin of error. If each bag should be 213 grams, what are the allowable number of grams for each bag? And here's the thing. It's a bit of a stretch to come up with a word problem for an absolute value inequality, all right? Most of you could probably do this, could go to the answer without doing the work of the absolute value, and I wouldn't expect you to do all the work with the absolute value, all right? The point here is that any word problem that would involve absolute value, we would typically solve another way. So let's think about the answer here first, okay? Let's think about it in terms of an inequality. It says each bag should be 113 grams, but there's a 5-gram margin of error, which means I can be off by 5 grams in either direction, all right? So if I'm supposed to have 213 grams, if I'm off in the low direction, like if I'm 5 grams too light, all right, it means that I would end up with 208 grams, all right? But if I was 5 grams too heavy, 5 grams in the other direction, I'd be at 218 grams. In other words, my value for x has to be greater than or equal to the 208, but less than or equal to the 218. This is the answer to this question, all right? If it asks us to write an absolute value inequality, and again, I just want to show you where the practical application of this comes from, is we'd be looking at this saying, hey, you know what? The 213 minus x, the absolute value of that has to be less than or equal to a 5, okay? In other words, to find the margin of error, I take the 213 minus the x, or the x minus the 213. Either one would be fine, and maybe it's probably better to do it the other way. But to find the margin of error, I would just say, hey, x minus what it's supposed to be, that difference has to be less than or equal to 5, or the absolute value of that difference has to be less than or equal to 5. And so as we kind of solve this thing, let me just set it up real quickly to show you we get the same answer that we have written over there. Oh, sorry, greater than or equal to. See, I'm trying to rush. And see, it's less than, so it's an and then I solve each. And notice, this seems strange. You're probably looking at me going, Mr. Jansen, why would I do any of that when the problem basically says to add or subtract 5 from the thing? Yes, you would absolutely not do the absolute value for this. You would go right to the answer. But this is where the application of this thing would come into play. Okay? So here's the 218. Over here, when I add that guy, here's the 208. Oh, that is probably the worst less than or equal to symbol I've ever drawn. And now, of course, I would rewrite it as one string. And there it is. I got the same thing that we got just by kind of thinking about it, okay? But hopefully you can see that even though this one was really easy to solve just by going right to the answer, where the application of the absolute value inequalities come into play. All right. But again, absolute value inequalities, we split them into 2 inequalities. When you do the negative version, you have to flip the inequality sign. And then remember, you have to use that and or qualifier with the inequality. If the absolute value is less than, it's an and. If the absolute value is greater than, it's an or. Okay. Less than is and, greater is or. All right. But again, you split it up into 2 inequalities and solve each. All right.